All right, this is 6.1, example 7. This is actually the fourth part to these notes. We're going to make sure that everyone is on top of things here. So please make sure that you're following along and all this. Now, one of the things that I taught you guys yesterday is when you go over this, each one of these arcs represent its own triangle. If I make it its own triangle, then I could actually go through and use that information. We had one of these on the warm-up today, where we had two of them, and we had two separate triangles, because I'm going to get an X, Y, and R for each one. So in this case right here, this is going to represent a triangle. Okay, so tangent is what over what? Y over X. Okay, so I'm going to make a triangle for it. So my Y value is what? Y value is what? U. And X value is? 1. Very good.
What?
Look, it's that right there, right?
Oh.
Okay, so how would I find the R? Pythagorean Theorem, very good. So it's going to be 1 squared plus U squared equals R squared. Right? So this is the exact same thing we do every time, but this time we don't have a number here. We're just going to, have some expressions for this. So since I don't know what U is, but I know what 1 squared is, right? How would I get R by itself? Nope. Nope. Square root. The opposite of square is square root, right? So I'm going to say that R is going to equal the plus or minus square root of 1 plus U squared. Now, I intentionally put plus or minus there because it's always going to be a plus or minus. But in this case right here, it has to be, why does it have to be plus?
It's R.
R. It's my radius. It's R. R is the radius of the circle. That's a distance. That's always going to be positive. Okay, so let's go through, and since that's going to be positive, I know that I have this is going to be square root of 1 plus U squared. Now, I have X, Y, and R, right? So now it's asking for sine given that. So sine of whatever angle of, I'm going to say theta in this case, has to be what over what? Y over R. So it's going to be U over radical 1 plus U squared. Yes?
Why is there a squared under the square root?
Okay, see this right here? Do you see this piece right here? So to undo a square, I'm going to square root both sides. And since I have to square root everything on this side, everything goes inside the square root. How'd you undo a square?
Why is it a U squared?
Pythagorean Theorem.
Well, doesn't a square root get rid of the
No. Because it's 1 plus. If it was just U squared by itself, so U squared, square root of U squared, would be just U. But since it's 1 plus, it's a 1 plus, 1 minus. If it's a binomial, I would have to have 1 plus U squared square root to try and undo that. So I'd have to have the whole quantity squared to undo that. But the problem is it's only one term that's squared. So it's got to be both things, but it's not in this case. So I just leave it as whatever that is. So I'm going to do a hypothetical. I'm going to throw in numbers now. Okay? Just so you guys could see this and hopefully it might understand it a little bit better. So I'm going to throw in, I'm going to use block. So hypothetical. So now let's say that's going to be 1. And let's make this one 5. So I have 1 and 5 here. Okay? Pythagorean Theorem says that this answer, the R, has to be what? it'd be 1 squared plus 5 squared equals whatever r squared is, right? So that would be 26, right? It should be square root of 26, shouldn't it? Say yes.
Yes.
Okay, so let's just plug it in right here. If I know what this one and this one is, so it'd be 1 plus 5 squared is 25, right? So that's 26, isn't it? So square root of 26, so it works out also if I plug it in right here instead. This is a way of writing my expression, just this side, whatever this piece, my u ends up becoming, I just plug it in there and then do the math. Does that make it a little bit easier now to understand why it has to be there? It can't just be the 5. Does that make sense? Okay, so that's why it comes out there. So if I throw in numbers, it still works out to be square root of 26, even if I just do my 1 squared plus 5 squared equals r squared. So 1 plus 25 equals r squared. 26 square root of 26. So either way, I get the same answer. It's the same thing. But now we're writing it as an expression this time. Okay, so now that's with numbers. So now right here, am I allowed to have a radical in the denominator?
You gotta rationalize.
Rationalize. So I'm going to go through and rationalize this. So I multiply top and bottom by
Square root
1 plus u squared, right?
1 plus squared.
Right? So now, am I multiplying that times itself?
Yeah.
So does that mean that those are going to be squared? Yes. So I'm going to have this and this times itself. So it's going to square. So what's going to happen to the radical?
It cancels out.
It cancels out in the denominator now. So now it's going to be sine of theta equals u radical 1 plus u squared over 1 plus u squared. Because the radicals cancel out when I multiply those. Okay, go ahead, ask. Say something. What part don't you like?
Nice.
I feel like if there was an X, I would get it more instead of a U.
Okay, so now let's go back to what I had over there in black. Let's say that there was the 5 and the 1 and the square root 26, right? I got my x, y, and r over here, right? Yes?
Yes.
X, y, and r over there. So let's go ahead and just plug those back in. Plug in my values. So this is going to be 5. This is going to be, so this would end up becoming 5 times rad 26 over 1 and 5 squared, 26. There we go. So it's the exact same thing, but now we're writing it as an expression that have variables representing those. But now, every time it's like this. Now, what we just basically did is we made it so every time it's going to work, and we would just plug in our numbers for what we have. Little sense or no? Okay, so let's try another one. I think I have another one like that one. Yes, I got another one right there. Are you done copying? No. Okay. All right, so on this next one, we're going to do the same thing. But I need you guys to have out your reference sheet, please. Remember the blue reference sheet. All right, did you get it? Okay. All right, so this is asking for cosine of 2 theta. That's asking for cosine of 2 theta. And I told you guys that this represents some angle, right? So there's my theta. Sine. What was sine representing? Y over r. So in this case right here, my y value is u, and my r value is 1. Okay. So now, if you need to, for your own sake, just put an x there instead, and let's do the algebra off of it. Pythagorean Theorem. I need to find whatever my x value would be, right? So it's going to be, let's see, this is going to be x squared plus u squared equals 1 squared.
Square root plus or minus square root of u squared minus 1.
So it's going to be x squared equals 1 minus u squared. Then it's going to be x equals plus or minus square root of 1 minus u squared. Now, does it tell me that this is going to be a positive or a negative? It doesn't. So on the previous problem, I said positive and negative, and I did that on purpose. But we're only working with the positive in that case because it was an r. This time I'm working with the x, and since I don't know yet, I don't know what quadrant this is supposed to be in, but it's going to be a positive or a negative. So we're going to find cosine now. Cosine of 2 theta. So now, this is going to be my x, y, and r here. So it's going to be plus or minus square root of 1 minus u squared. All right, double angle identity. The blue paper. Blue paper, double angle identity. And I want to use the, let's do 2 sine squared minus 1. I think that's what it is. Before I,
Yes, sir.
okay, no, other way.
1 minus.
1 minus 2 sine squared. Sorry, got it backwards. So, we're going to use 1 minus 2 sine squared. Okay. Why would I want to use sine instead of cosine?
Okay, you got
For the variables it uses. I don't know. Because we have.
Is this ugly?
Yes.
Your highlighter ugly.
It is very ugly. Okay. This is not nice. So that's why I want to avoid that in my equation. So since I'm only looking for cosine, and in this case cosine could be whatever I want, do I want to plug in the x value anywhere? Say no. No, it's going to be ugly, so I don't use it. So it's going to be, so cosine of 2 theta is equal to 1 minus 2 sine squared theta, right? Say yes.
Yeah.
Okay, so do we know what sine is? Yeah, sine's going to be what? U over 1. So it's basically going to turn into 1 minus 2.
U squared.
It's not bad. Not too bad? Okay, speak, ask questions. Now's the time.
Is that it, or you got some more?
That's it. We got it. We plugged into one of my formulas. And I used the formula to avoid my x value, which is going to be a plus or minus square root of, all that. Now, for the sake of argument, I'm going to plug it into the one with the x value. Just because I want to mess with people.
You want to watch the world burn.
Yep, some people just like to watch the world burn. So cosine of 2 theta equals 2 cosine squared theta plus 1.
Minus 1.
It's minus 1, you're right, sorry.
What are you doing?
I was about to take my Gatorade.
Okay, like I said, I'm just going to watch the world burn. So, it's going to be 2 plus or minus square root of 1 minus u squared, right? Squared minus 1. What happens when I square a negative?
It becomes.
It becomes a positive.
What happens when I square a square root?
It disappears.
So either way, the positive or negative are going to go away, right?
Yeah.
And my radical is also going to go away, isn't it?
Yeah.
So now it's going to turn into 2 quantity 1 minus u squared minus 1. So that's going to distribute 2 minus 2u squared minus 1, which gives me 1 minus 2u squared.
Nice.
I feel like that was easier.
Nice.
The other one was easier. I like that one.
Do I get the same answer?
Yeah.
A little bit less work.
And no cussing.
All right. Finding the optimal angle of elevation of a shot put. So let's say, for instance, I have the blueberry.
Be careful. You might get that.
I have the blueberry, and I'm trying to find the optimal angle to throw it and hit someone in the head. So, and it's usually someone that's not paying attention because they have their phone out in front of them, even though they think I cannot see it because it's behind your hydro flask.
Behind the calculator.
Now you just put the calculator there. Now it's just horrible.
Hit her, hit her.
So, listen. Away. Thank you. All right.
If I was on it, the bell would be jingling.
Now, so for this one right here, we're going to go, and there's an equation for this.
I don't like this already.
Shh. Shh. Okay. There's an equation for this. We're just going to try and find the angle here. So we have velocity, which is given to us. It's v. So you have a variable v here, variable v here. Okay. You have an h, which is there, right? Do we have all the numbers? So what do you do from this point? Plug it in where? Just plug it into the calculator. Plug it into the calculator.
Oh, that's
Plug it into the calculator.
right now.
Yes, right now.
I'll do it tomorrow.
Plug it into the calculator.
It gives you
Give me
the
a
answer.
second.
Right now, you are plugging in the calculator.
Oh,
It gives you the variables so you have the answer.
All the variables are given to you. You just have to plug it in the calculator. You're plugging it in the calculator.
who are you yelling at me? Or?
No, him this time.
This time.
Well,
Because I know everyone is plugging it in the calculator. Everyone should be plugging it in the
I
calculator.
got a decimal.
What mode should the calculator be in?
I don't know.
Degree.
Why is it going to be in degree?
Why is mine
Because it's some arc sign.
Mine's in degree, and I got a decimal. I got a decimal too.
Oh, then in that case it should be in decimal.
Do you have arc sign first?
Oh.
Yeah, mine was in degree. I was in radian. I don't know. 41.9. Technically 42.
Let's see. Here, I'm in rad, so let's change it. 7.2 degree. So, the whole thing just closed. That sucks.
It's 42.
Should be about,
Wait.
Where's arc sign on here?
It's sign with the mind underneath sign. That's what arc means. It's a negative one. Negative one thing.
It
All right, so this is actually kind of like a perfect problem because we have track and field going on right now, right? And everyone is going to be doing, let's see, Doc 7, 2.
Yeah, 41.9.
I didn't finish it because you changed it.
Square root, control, divide. What was my velocity?
42.
Okay, 42 squared over
2 times
Times 42
42
squared
squared
plus 64 times 6.6.
plus 64.
and was it plus?
Yeah. Plus
Oh
64.
my gosh, I got
And plus what?
64.
64.
Yeah, times 6.6.
Oh, I cannot talk about it.
So it comes out to be about what?
42.
42 degrees. ¿Está muy fácil?
Yeah.